Hello everyone, I hope you are all fine. This week we will start discussing a new topic called sales and operations planning. In the previous weeks we talked about forecasting, and now the aim of this new topic is to present you the process by which companies go from technical forecast to aggregate level sales and operations plans. As we go through life, we make many decisions, and we can categorize these decisions into two groups as micro decisions and macro decisions. If I give some examples for micro decisions in our daily life, these can be what to eat for breakfast, what route to take to work, what auto service to use, or which movie to watch. Or let's give some examples for the macro decisions that we make in our life. For example, where to live, what to major in, which job to take, whom to marry. And also, the companies make both micro and macro decisions. And these macro decisions are sometimes highly strategic. For example, which process technology to choose, or market entry choices. And some of these macro decisions are more tactical. For example, planning company-wide workforce and production levels or setting sales targets. And in this week, we explore tactical decisions made at the macro level in the context of a process known as sales and operations planning. Now let's talk about sales and operations planning. Sales and operations planning begins with demand forecast and turns them into targets for both sales and operations plans. It begins with demand forecast, but companies may not prefer to use these forecasts blindly. What I mean is that the companies may prefer to produce more than that forecast or less than that forecast. Think about the cases when a company may prefer to produce more than its forecast. For example, if they are planning a major promotion for their products, or if stockouts are unacceptable. What I mean with stockouts is that if the company cannot supply the demand, we call this as stockouts. And if they are unacceptable, in that case, the company may prefer to produce more than the forecast. Or on the other hand, companies may also prefer to produce less than its forecast. For example, if they see that the product is winding down in its life cycle, or overstocks are very costly. But of course, to be able to make such decisions is not very easy. Such decisions must be made at a high strategic level. Also, to be able to make such decisions, the companies should make a balance between its departments. Think about the sales department. The performance of the sales department is mostly measured with revenue. For that reason, they want the products 100% available with as many different varieties as possible. On the other hand, the performance of the operations department is measured with cost. And for that reason, they want to keep both capacity and inventory cost low, which means limiting overproduction and product varieties. For that reason, there is always a conflict between sales department and operations department. Before starting to work in this university, I was working in a furniture company. And while I was working there, I was also attending such meetings about sales and operations planning. And in those meetings, I saw many discussions between these two departments. For example, sales department takes an order from a customer and requests production department to produce this order. But the production department says that the amount of this order is not enough. When we produce this product, we have to produce in this amount, and when you take this order, we will produce this in a higher amount, and we have to keep the rest of the products in the inventory, which will increase our inventory cost. So it is worthless to accept this order. But on the other hand, sales department wants to keep their relations with the customers as good as possible, and for that reason they insist on the production department to produce these products. So it is important to make a balance between these departments. And one of the key goals of sales and operations planning is to resolve the fundamental tension between sales and operations divisions in an organization. Here you can see the balance between demand and supply. Demand is a function of sales effort, and pricing and supply is a function of operations effort and capacity. Therefore, in order to best balance supply with demand, a strategic approach must be applied. Sales and operations planning is a business process that links the corporate strategic plan to daily operations plans and enables companies to balance demand and supply for their products. We can call sales and operation process as a business process. Each business will apply its process slightly differently, but some common elements include the following. Firstly, it is strategically focused. Secondly, there is cross-functional team. Thirdly, it is aggregated. And lastly, there are time fences. Let me explain these one by one. Firstly, what I mean with strategically focused is that finding the appropriate balance for supply and demand requires knowledge of the company's strategic plan. For this reason, typically C-level executives, for example CEO, CFO, are involved in sales and operations planning to ensure that the company's strategy is appropriately represented. For example, if stockouts are not allowed, then plans should be made according to this strategy. And secondly, sales and operations planning process must balance the interests of different parts of the organization. In fact, we talked about that. As I mentioned, there is mostly a conflict between sales and production department. For that reason, sales and operations planning must balance the interest of these different departments. Thirdly, sales and operations planning processes typically work with aggregated units of production, such as product families. It is typically not possible to forecast at the individual stock keeping unit level. What I mean with product families is that, for example, I want to give examples from the furniture company again. For example, dining rooms, bedrooms are product families. Of course, there are special type of dining rooms and bedrooms. But firstly, the company makes aggregated plans. For example, the company makes plan for the next week to produce 5,000 dining rooms. This is an aggregated plan. And according to this aggregated plan, the company also makes plans for its workforce. After making the aggregated plan, then they disaggregate this plan and they decide the number of the product types, I mean dining room types. They decide to produce 100 A model dining room, 200 B model dining room, etc. But firstly, the aggregated plan is made. After that, this plan is disaggregated. And lastly, there are time fences. The agreed sales and operations plan will typically be only fixed for a relatively short period, for example, a week or a month. A forecast for future time periods will typically be assumed to be flexible within a given range. Now I would like to talk about the key inputs required for the sales and operations planning process. Firstly, technical demand forecast. This is the forecast that we talked about in the previous lectures. Advanced forecasting techniques are used to understand raw demand. Secondly, sales plans. The marketing and sales divisions will use the technical forecast and their own promotion and marketing plans to provide a sales forecast. And thirdly, operations plans. Operations will produce a production plan that includes plans for capacity, supply, and inventory. Fourthly, innovation plans. The planned roll out of new products and future product innovation must be considered in the context of sales and operation plans. And lastly, financial plans. The sales and operations plans must also consider the financial forecast. In many smaller companies, cash flow constraints must also be considered in the planning process. The basic sales and operations planning process must iterate between these 5 key inputs to resolve tensions and unforeseen constraints to finalize the sales and operation plans for the company. What I mean with unforeseen constraints is that I can give an example. For example, there may be a supplier who cannot deliver until 6 weeks from today. These unforeseen constraints should also be considered while making these plans. As I mentioned, there should be iterations between the inputs of sales and operations planning process. Here is a figure that shows the monthly sales and operations planning cycle. In the first step, there is the demand review, and after this step, we have the demand plan. And in the second step, there is supply review, and after this step, we have the demand, supply, and inventory plans. But there can be some unresolved issues, and for this reason, in the third step, there is an alignment meeting. What I mean with this alignment meeting is that there should be cooperation between the departments of the company. And after this meeting, there is the proposed sales and operations plan. But still there can be some unresolved issues and scenarios for resolution. What I mean with scenarios is that there can be some uncertainties. And in the fourth step, there is the management review meeting. And after this step, we have the revised marketing programs or changes to any other demand drivers. And this committed sales and operations plan is sent to again demand review. As you can see, these iterations continue. And also on the right side, you can see there is weekly planning cycle, and there is always communication between monthly sales and operations planning cycle and weekly planning cycle. And now this figure shows the operations carried out in a company at different decision levels. Here you can see there are operations at the strategic level. Here there are operations at the tactical level. And here there are operations at the operational level. In fact, this is a framework prepared for a company. Here you can see that sales and operations planning both belong to strategic level decisions and also tactical level decisions. In fact, we already discussed about forecasting that belongs to strategic level decisions. And here we will discuss this aggregate production planning, and we are already discussing sales and operations planning. Also, there are other operations such as master production scheduling, material requirements planning, production scheduling that we will discuss in this course. Now I would like to talk about key performance indicators. Shortly, I will call them as KPIs. KPIs are important to measure the performance of the operations in an organization. Also, they are one of the quantitative inputs to the sales and operations planning process. KPIs may change according to the objectives of different departments in an organization. For example, the CFO may present key financial performance measurements as net profit and return on investment. But instead of concentrating on pure finance measures, it is better to concentrate on a more well-rounded performance measurement approach covering a wider scope of metrics. And now I will introduce you an approach called balanced scorecard approach, and this approach provides a more well-rounded performance measurement approach. Here is this approach. In this approach, there are 4 perspectives. These are internal, financial, customer, learning, and innovation. And as you can see from the figure, in fact, overall strategic objectives cover all these perspectives. According to the internal process performance perspective, we ask the question, what must we excel at? We ask the question, what must we be good at? And according to financial performance perspective, we ask the question, how do we look to shareholders? And according to customer performance perspective, we ask the question, how do customers see us? And according to the learning and innovation performance perspective, we ask the question, can we continue to improve and create value? By asking these questions, we determine the KPIs. Operational metrics typically sit within internal process measures, and we can classify operational KPIs into 2 groups as efficiency-related KPIs and effectiveness-related KPIs. Efficiency-related KPIs are the measure of resource utilization, for example, time, cost, materials, and etc. And effectiveness-related KPIs are the measure of how well the process meets or exceeds customer requirements. For example, defects, complaints, satisfaction score, and etc. In fact, which of these are most important will depend on the product line strategy. For example, if your products compete on cost, then efficiency being KPIs become more important. But if you have high margin products that compete on innovation or fashion dimensions, in that case, effectiveness related KPIs become more important. One of the key challenges in choosing KPIs is in achieving organizational alignment. KPIs must be aligned to the strategic plan in order to monitor the essential performance results implied by the vision and mission statements and to monitor current strategic goals or objectives. It is then recommended that they be cascaded down to the business processes to maintain alignment. Finally, The KPIs may be aligned to business units once they have been associated with business processes. Going the opposite direction, starting from business units, is more likely to result in misaligned KPIs. One of the key challenges in sales and operations planning is the effective management of uncertainty and risk. Since sales and operations planning is the highest level of tactical planning in an organization, it must explicitly acknowledge major sources of uncertainty and moreover explicitly work to manage and mitigate risk. There are mainly four different types of uncertainty. They are variation, foreseen uncertainty, unforeseen uncertainty, and lastly chaos. Let's examine all these uncertainties one by one. Firstly, variation is anything that causes the system to depart from regular, predictable behavior that may be described by a probability distribution. For example, variability in customer orders, differential worker skill levels, and variability in quality or lead times. Secondly, foreseen uncertainty. We can call this as also known unknowns. These are risks that can be foreseen and planned for, and they can be described by a probability of occurrence and have a larger impact than variation. Typical sources include supply breakdowns, design changes, natural disasters, labor strikes, and etc. Thirdly, unforeseen uncertainty. We also call this as unknown unknowns. They are risks that could not be predicted ahead of time or that are considered too unlikely to make contingency plans for. For example, natural disasters of unusual scale or in regions where they do not typically occur, or competitor innovations that were not anticipated. And lastly, chaos. Chaos is also unforeseen uncertainty, but in this case, the event not only affects the operations, but also it affects the fundamental goal of the project or company. For example, there was an earthquake in 2010 in New Zealand, and there a number of local beverage manufacturers offered to switch to bottling water instead of regular products. And the goal for the beverage manufacturers shifted from profit from beverage sales to humanitarian aid. Each of these uncertainties that I talked about must be dealt with and planned for in different ways, and all require a firm to have effective management and communication processes. And let's talk about the strategies used by operations to mitigate variation. For example, companies may prefer to hold inventory or maintain excess capacity or incur deliberate delays in order fulfillment to mitigate these variations. It is foreseen uncertainty that is best dealt with explicitly within the sales and operations planning process. For example, if it is known that a supplier is currently struggling with labor issues, then it should be discussed at sales and operations planning meeting what plans should be put in place for the event that the supplier's workforce goes on strike. Unforeseen uncertainty may be mitigated by generic contingency plans and good leadership, while chaos requires strong leadership and crisis management processes. By definition, Neither unforeseen uncertainty nor chaos may be explicitly planned for in the sales and operations planning process. However, an organization with strong cross-functional ties, which good sales and operations planning processes foster, is going to manage such occurrences better than an organization with little cross-functional planning. Now, I would like to talk about aggregate planning or capacity. The operations division uses the sales forecasts that comes out of the sales and operations planning meeting. And with these forecasts, they are responsible for determining an aggregate production plan for capacity usage throughout the planning horizon. In fact, they determine aggregate production quantities and levels of resources required to achieve these production goals. In practice, they find the number of workers that should be employed and number of aggregate units to be produced in each of the planning periods. And the aim while preparing an aggregate production plan is to minimize the total cost that occur in aggregate capacity planning. Here are the costs in aggregate capacity planning: smoothing costs, holding costs, shortage costs, regular time cost, overtime and subcontracting cost, and lastly idle time cost. Now we will talk about them one by one. Firstly, smoothing costs. Smoothing costs occur when we change the production levels from one period to the next. Think that when we increase the amount of production, then we should also increase the size of the workforce. But if we decrease the amount of production in a period, then we should decrease the size of the workforce. And increasing the size of the workforce requires time and expense to advertise positions, interview prospective employees, and train new hires. On the other hand, decreasing the size of the workforces means that workers must be laid off, and severance pay is thus one of the costs of decreasing the size of the workforce. Moreover, firing workers could have far-reaching consequences. For example, firms that hire and fire frequently develop a poor public image, and this could adversely affect sales and discourage potential employees from joining the company. It may adversely affect employee morale. For that reason, it is recommended to work with a constant level of employees. It is not recommended to hire and fire employees frequently. Here is a graph showing a typical cost function for changing the size of the workforce. The x-axis here shows the number of hires, and here shows the number of fires, and y-axis shows the total cost. Here, the slope of this line shows the unit hiring cost, whereas the slope of this line shows the unit firing cost. And in this graph, it is assumed that the cost function is linear. In fact, up to a certain point, this linear cost function is reasonable. But for example, think that after a point when you need to hire more workers and more workers, the supply of labor may become scarce. In that case, you may need to add some additional cost to be able to hire a new worker. So, in fact, this cost function may not be linear. Instead of that, it may become exponential. Now, holding costs. Companies may hold inventory for different reasons. One of these reasons is that to keep the employee level the same. Or, we talked about uncertainties, we talked about the variation. To mitigate this variation, companies may prefer to hold inventory. When they hold inventory, in fact, they tie up their capital in inventory. Instead of tying up their capital in inventory, they may invest this capital elsewhere with a return. And for that reason, when they hold inventory, they have a holding cost. And holding costs are almost always assumed to be linear in the number of units being held at a particular point in time. We will also assume that the inventory holding cost is linear. And also, we will assume that holding costs are charged against the inventory remaining on hand at the end of the planning period. In fact, holding costs could be charged against starting inventory or average inventory as well. And shortage cost. Companies sometimes may have negative level of inventory. What I mean with negative level of inventory is that sometimes the demand exceeds the capacity of the production, and in that case the company may not meet all the demand. Generally, it is assumed that excess demand is backlogged and filled in a future period. But sometimes, if there is a highly competitive situation, it is possible that excess demand is lost and the customer goes elsewhere. And in this case, it is known as lost sales. And like holding cost, shortage costs are generally assumed to be linear. Convex functions also can accurately describe shortage cost, but linear functions seem to be the most common. Here is the graph showing the holding and backorder cost. Here we see the positive inventory, and here there are back orders. The y-axis shows the cost, and the slope of this line is the unit inventory holding cost, and the slope of this line is showing the unit cost for each back order. And now regular time cost. Regular time cost involve the cost of producing 1 unit of output during regular working hours. And in this category, cost of regular employees working on regular time, the direct and indirect cost of materials, and other manufacturing expenses are included. And if all the production is carried out on regular time, now this regular time cost may become fixed cost. I mean, the number of units produced must be equal to the number of units demanded over any planning horizon of sufficient length. And if there is no overtime or worker idle time, then this regular payroll costs do not have to be included in the evaluation of different strategies. Overtime and subcontracting costs are the cost of production of units not produced on regular time. Companies may not be able to produce all the units on regular time. In that case, they may produce the units beyond the normal workday, again by regular time employees, and we call this as overtime. Or they may prefer subcontracting. And what I mean with subcontracting is that is the production of items by an outside supplier. And again, for both of them, for overtime and for subcontracting, we assume that costs are linear. And lastly, idle time cost. In fact, there may be underutilization of the workforce or idle time during the production. But most of the time, we assume that this idle time cost is zero because we already include this cost as labor cost, and also this result in lower production levels. However, idle time could have other consequences for the firm. For example, if the aggregate units are input to another process, idle time on the line could result in higher cost to the subsequent process. In such cases, one would explicitly include a positive idle cost. Now, I would like to give you an example for aggregate production planning. In this example, there is a company called DensePack that produces these drives, and DensePack tries to make a production plan for 6 months period, January to June. And here in this table, demand belonging to each of the months is given. And at the beginning of January, already 300 workers are employed in DensePack. And it is given that at the beginning of January, there is an inventory of 500 units, and at the end of June, it is expected to have 600 units on hand. And now we will calculate the net predicted demand. The demand for January was given as 1,280. Since we know that we have an inventory of 500, we subtract this inventory from the demand and obtain the net predicted demand. Also, we are expecting to have an inventory of 600 at the end of June, and the demand for June was given as 1,400. So we add this inventory to this demand, and we calculate the net predicted demand for June as 2,000. Here in the last column of the table, net cumulative demand is given. Also, in the question, it is given that cost of hiring one worker is $500, cost of firing one worker is $1,000, and cost of holding one unit of inventory for 1 month is $80 per unit. And in the question, it is given that the plant manager observed that over 22 working days, with the workforce level constant at 76 workers, the firm produced 245 disk drives. This means that on average, the production rate was 245 divided by 22, that is 11.1364 drives per day, when there were 76 workers employed at the plant. And it follows that one worker produced an average of 0.14653 drive in 1 day. And we call this number as the number of aggregate units produced by one worker in 1 day, and we call this number as K. And for this example, this number is 0.14653. And finally, in the question, the last data given is the working days, the number of working days per month per each of the months from January to June are given. And this graph is showing a feasible plan for DensePack. Here we see the cumulative demand, and this line shows us a feasible production schedule. And as you can see, there is a constant workforce. But when we have constant workforce, in fact, we have to hold inventory, as you can see. And this is one of the strategies that DancePack can have. And this strategy is called as level strategy. I mean constant workforce plan. And under this strategy, capacity is kept constant during the planning period. For example, no workers are hired or fired. And instead, inventory is kept between periods and capacity is set to the minimum possible to ensure no shortages in any period. And for this example, at the beginning of the first period, we already had 300 workers. And by hiring 111 workers at the beginning of January, we had a constant workforce of 411 workers. And with this constant workforce, with this production plan, we have a total cost of $580,460. And instead of that, we may have another strategy called chase strategy. And in this strategy, this is also called zero inventory plan. And under this strategy, the workforce is changed each month in order to produce enough units to most closely match the demand pattern. Capacity is adjusted up and down. For example, workers are hired and fired to achieve this matching. And according to this example, when we apply this strategy, we hired a total of 755 workers and fired a total of 145 workers and achieve a total cost of $572,900. As you can see, in fact, both of the costs are very close to each other. In fact, if the company will choose one of these strategies, probably the company would prefer to choose constant workforce plan because, as I talked about it before, firing and hiring workers may have other consequences. So instead of hiring and firing workers, the company may prefer to hold inventory and may prefer this strategy instead of zero inventory plan. Besides these two strategies, I mean chase strategy and level strategy, then we may have another strategy called mixed strategy. In this mixed strategy, we may both hold inventory and also we may both fire and hire workers. But of course, it is important to know the amount of inventory that we will hold or the amount of employees that we will hire and fire in each period. And to be able to determine the optimal levels for each of them, we should use linear programming formulations for this strategy. Now I will introduce you a linear programming formulations to use for aggregate production plans. Firstly, let me introduce you cost parameters and given information. We need these parameters to be able to develop such a linear programming formulation. Firstly, cost of hiring one worker, cost of firing one worker, cost of holding one unit of stock for one period, cost of producing one unit on regular time, incremental cost of producing one unit on overtime, idle cost per unit of production, cost of subcontract one unit of production, number of production days in period T, number of aggregate units produced by one worker in one day, initial inventory on hand at the start of planning horizon, initial workforce at the start of planning horizon, and lastly, forecast of demand in period T. And these are our decision variables. Firstly, of course, we define an index called T for our periods. And now these are the decision variables that we are trying to obtain their values with our linear programming formulation. WT is the workforce level in period T. PT is the production level in period T. IT is the inventory level in period T. HT is the number of workers hired in period T. FT is the number of workers fired in period T. OT, overtime production in units. In fact, we have OT when PT is greater than K multiplied with NT multiplied with WT. K, is the amount of production by one worker in one day multiplied with the available working days in period T and multiplied with the workforce level in period T. In fact, this part gives us the amount of production in regular time. If PT, production level in period T, is greater than this part, then we have a positive number for OT, that is overtime production in units. Or it can be opposite. If the amount of production in regular time is less than production level in period T, in that case we will have a positive UT value, that is worker idle time in units. And lastly, ST, number of units subcontracted from outside. And here is our objective. Our objective is to minimize the total cost. And in this total cost, we have minimizing hiring cost, firing cost, inventory holding cost, regular production cost, overtime cost, underutilization cost, and subcontracting cost. And in our constraints, firstly, in part A, constraints A shows us the conservations of workforce. WT, that is workforce level in period T, is equal to workforce level that belongs to the previous period plus number of workers hired minus number of workers fired. And secondly, constraints B give us production and workforce, that is PT production level is equal to K multiplied with NT multiplied with WT. I explained this. This is the total amount of production in regular time plus amount of production in overtime minus UT, that is the worker idle time in units. And in constraint C, inventory balance is given. That is, inventory hold in period T is equal to inventory hold in the previous period plus production level plus subcontracting level minus demand level in that period. And lastly, we have the non-negativity constraint. And when we solve our example, the example that belongs to the Spec company, with this linear mathematical formulation, we obtain a cost of $379,292. You can see that with these first two strategies, in fact, we obtained cost very close to each other. But with this mixed strategy, we obtain a value, a cost that is dramatically less than the cost that we obtained with these two strategies. So you can easily see that for this problem, it would be better to apply mixed strategy. Now that's all that I would like to talk about sales and operations planning in this video. Thank you for listening.